Hello. So over the weekend, you guys watched a video and it introduced the topic of shifts. And it covered pages 22 and 23 in your packet. So what we're going to do in this video is we're going to take what you learned and we're going to apply it to examples, and we'll be covering pages 24 through 27 in your Unit 5 packet. Now, I just want to point out, please make sure you take really good notes on everything you hear in this video, as well as whatever you hear in tomorrow's video. Because on Friday, you are going to be having an open notebook quiz. So you can use your notes. So please make sure to keep very good notes. Okay, now make sure that whatever we talk about in here, you're keeping very good notes. Because on Friday, you guys are going to have an open notebook quiz, which we don't normally do. So the better your notes are, the better you'll do on the quiz. Okay, so if you turn to page 24 of your packet, you'll see that it starts on number 40. And these are the rules from the previous page and from what you watched on the video over the weekend. But basically, let me just quickly go over them. Basically, it says here that if you add a number to a function, it shifts it up. If you subtract a number from the end of a function, it shifts it down. If you add a number within a function, it shifts it to the left. If we subtract a number within a function, it shifts it to the right. And if you negate a function, it basically just reflects that graph right over the x-axis. Okay, if for some reason you did not watch the video over the weekend, please stop right now, go back and watch the original video just so you have an introduction of this, and then you can come back to this. If you did watch the video, I'd like you to try this page on your own, numbers 40 through 44, and you could hit stop, try them on your own, and then you could hit play and see how you did. Okay, so number 40 says the minimum point on the graph of the equation y equals f of x is -1, -3. So I plotted a point right here at -1, -3. It says what is the minimum point on the graph of the equation f of x, y equals f of x plus 5. So remember, if you're adding a number to the end of the function, it says we're going to take that graph and move it up 5 units. So if we take this minimum point and move it up 1, 2, 3, 4, 5 units, let me just put a point right there, we'll see we wind up right here. And the coordinates at that point are -1, +2. Okay, so choice 1 will be the answer. We're just going 5 units up. Okay, number 41 says the maximum point on the graph of the equation y equals f of x is 2, -3. So right here. They want to know what is the maximum point on the graph of the equation y equals f of x minus 4. Now, if you notice, we're subtracting a number within a function. Okay, look at our rule up here. When you subtract within a function, it moves it to the right. So this is telling us we're going to take our point and move it 4 units to the right. So if I'm at 2, -3, if I go 4 units to the right, so 1, 2, 3, 4, I'm going to be right here. Okay, so this is at 6, -3. All right, so let me put a point right here. So I'm moving 4 units to the right. So my answer is going to be choice 4, 6, -3. Okay, let's take a look at number 42. Now, I brought the rules down here so we could see it. All right, so we want to know what transformation would map f of x onto g of x. Well, let's look here. See how this is, there's a negative in front of f of x, but there's not in front of g of x. That means if something was negative and now it's not, it means we negated the function, right? If you negate a negative, doesn't it become a positive? So when you put a negative in front of the function, when you negate a function, you reflect over the x-axis. So far it has to be choice 3 or 4, right? We have reflection in the x-axis. Now, if we look here, like we're adding a number within the function, right? Within the radical. If it occurs within, that's going to move it to the left or the right. And remember, if it's an addition, it moves it to the left. So we could see right here, we're moving to the left 4 units. And then wouldn't this -6 at the end, right? When you subtract something from the end, it moves it down. So it's going to be down 6 units. So choice 3 is our answer. All right, number 43. Which of the following could identify the transformation of a parabola with a vertex of -4, -6 to a parabola with a vertex of 1, -6. Okay, let's draw this out. Okay, so we're starting at the vertex, right? Just basically like the very lowest point of a parabola or the very highest point of a parabola. But either way, it's right here at -4, -6. Now we're shifting it. So now the vertex is at +1, -6. So we're shifting. Well, look, which direction are we shifting here? We're going to the right. So when you shift to the right, you subtract the number within the function. Okay, now we shifted to the right 1, 2, 3, 4, 5 units. So we're going to subtract 5 within the function. So choice 4 would be the answer. Okay, now number 44. This one was a little tricky. I'm sure some of you chose, let's see, choice 1. Some of you probably saw this and said, look, I'm adding 2 within the function, so I'm going 2 units to the left, and I'm subtracting 1 with to the end of the function, so I'm going, look at that, 1 unit down. So I'm sure some of you put choice 1, but be careful, okay? This is our original function, not y = x squared. So if you look at the x squared, right? Within the x squared, we did add 2 to the function. So if you add a number within the function, right? Add a number within the function, you are going to the left. But our original function was starting off with a +3 at the end. So think about it. If we're starting off with a +3 at the end, right? And we're winding up with a -1. Think about if we're starting off 3 units up and then we're winding up 1 unit down. Aren't we actually going down 4 units, right? Isn't 3 minus 4 -1? So this is actually going down 4 units. If you want to see that visually, think about it like this. We're starting off at a height of +3, and we're ending off at a height of -1. So didn't we go down 1, 2, 3, 4 units? So in this case, choice 2 is our answer. All right, let's take a look at the next page. Okay, I'd like you to do the same thing as we did on the previous page. I'd like you to try out these 2 examples on page 25, and then, just stop the video, try them out, and then when you're done, hit play and see how you did. You could check your work. Okay, so they give us this picture of f of x, and they want to know which graph represents g of x if g of x equals negative f of x. Remember, when you negate a function, we're reflecting over the x-axis. So here's your x-axis. Basically, whatever's below it is going to be above it. So like this part down here is going to be up here, right? So it's going to be, this isn't going to be a great triangle, it's going to be something like that. And then if this dips below the x-axis, but we reflect over it, if we reflect over the x-axis, it should be above the x-axis and come down. It should look something like that, which looks like choice 1. Okay, so choice 1 is our answer. Basically, anything above the x-axis comes below it, and anything that was below it comes above it. So that's what our graph should look like, choice 1. All right, number 46. So they're just telling us that this graph represents national and New York State average gas prices. So they're saying New York State is this one up here, right, the one above it, and the national is the one below it, the one with the asterisks. Okay, so if New York State's gas prices are modeled by G of X, so we're saying G of X is New York State's. I'm going to label it. So G of X is this one, right? G of X. They just want to know which expression best approximates the national average. Okay, so the national is this one below it. Now let's think about it. The national is shifted down from New York, which makes sense, right? New York is usually more expensive. So if we're shifting down a certain number of units, right, look at this. This means, choice 1 means we're shifting to the left. Choice 2 means we're shifting up. Choice 3 means we're shifting to the right. And choice 4 right here means we're shifting down. So choice 4 would be the answer. All right, so take a look at page 26. And same thing. Hit pause, right, try these out, and then hit play and see how you did. Okay, so in 47, they just wanted us to describe the transformation of really what happened to go from P of X to Q of X. Okay, so we could see right here, see how this just says 2 to the x? Well, within this function, right, within the exponent, we subtracted 3. So remember, if you're subtracting a number within the function, that's going to bring you to the right. So this is bringing us to the right 3 units. Okay, I'm going to write this out in a minute. I'm just kind of labeling my notes. Now, if we look here to the end of the function, we added a number, right? We added 4. So if you add a number to the end of the function, doesn't that move us up? So that's moving us up 4 units. Okay, so it says to describe. So I'm going to write this out in a sentence. I'm going to make it nice and neat. All right, so there we go. So I'm just being more specific. The new function, q of x, is shifted 3 units right and 4 units up. Okay, so there we go. All right, and then 48. So they want us to consider this function, h of x, right here. And they want to know which equation could be used to represent the graph shown below. Well, if you look at this graph and then look at this graph, didn't we just basically take this and reflect it over the x-axis? Okay, so if you think back to our rules, when we reflect over the x-axis, all we do is we negate the function itself, which is being shown right here in choice 3. Okay, choice 4 is not the answer because in choice 4, they're negating the x. We don't want to negate the x. We want to negate the function itself. So choice 3 is our answer. Okay, so try out number 49. This is the last one we're going to do today. This is on page 27. And this question may look familiar. We actually did this question in Unit 2. So now that we're talking about shifts, we can kind of look at it from a different aspect, but we've done this exact question before. So hit pause, try it out, and then hit play and see how you did. Okay, now first of all, when they say they want us to write an equation for f of x, we have to look at our zeros. Now we see that we have zeros at x equals -4, x equals 0, and x equals +3. Now let's think about that. If we know our zeros, don't the factors have the opposite sign? And they need to be written in factored form. So if we have a 0 of x equals -4, the factor would be x plus 4. If we have if we have a 0 at x equals 0, the factor would be x minus 0. Or really, x plus 0, but either way, think about it. If you have x and you take away 0, aren't you really left with just x? So I'm actually going to rewrite this factor as just x. And then if we have a 0 at x equals 3, wouldn't the factor be x minus 3? Now, we have 1, 2, 3 factors here. But isn't this a 4th degree function, right? 1, 2, 3, 4. So what that means is one of these factors must have multiplicity. We must have 2 of the same factor. And do you guys remember when it bounces off the x-axis? That means we have multiplicity. So I'm going to put a square on this factor. Okay, so now let me make that better. There we go. Okay, now let's write the equation. So it says write an equation for f of x. So I'm going to write f of x equals, and they tell us up here that the leading coefficient is 1. So if you want to put a 1 in front of this, you can. But you don't need it. I'm actually not going to write it. Okay, now we know we have factors of x plus 4, x squared, and x minus 3. I'm going to put the x squared first. Usually put your squared terms first, right? And then I'm going to bring down the x plus 4 and the x minus 3. And I'm going to recommend that you do not multiply this out unless they say they want it in standard form, which would mean you'd have to multiply all this out. I would leave it like this in factored form. Okay, so this is our equation of f of x. Okay, now it also says, let me just give myself a little more room. It also says the function g is formed by translating function f left 2 units. Now, if we want to shift something to the left, aren't we going to add that number within the parentheses? So within each of these parentheses, although there's no parentheses here, but we're going to need to put it within, let me say, each of these factors, we are going to need to add 2. Okay, so that tells us we're going to need to add 2 within the function, so within each parenthesis. So let's write this. So g of x equals, now if I add 2 to this, right, I'm just going to write it as x plus 2 and bring down the square. So I'm just adding the 2 to the x. Now if I add 2 to this, isn't 4 plus 2, 6. So this will be x plus 6. And if I add a 2 to negative 3, is it negative 3 plus 2? Negative 1. So that'll give me x minus 1. And there we have it. There is g of x.